So the concepts of stability got over in the previous class, wherein we understood few concepts, like if a system is given, we can go calculate, write the characteristic equation first, and using the characteristic equation, we can identify whether the system is stable or not at first. So that the method is RH criterion. You apply that criterion to find that. Okay, and the second the thing is that if there is a unknown parameter as gain, so k is a gain of the system, right? We understood that only for a specific ranges of k, the whole system remains stable. That is because as the k varies, the poles of the system will move around in the s plane, and we know that pole should be within the left hand side of the s plane, or worst case on the marginal value, that is on the y axis. If the poles move to the right side, system becomes unstable, and we know that for certain values of k, right, as we vary the k from minus infinity to plus infinity, definitely it's going to change. So we saw that it's 0 to some value, we have a range of k for which the system is stable. Okay, now we move on to the next technique, wherein we analyze the stability of the system once again by using a plot. Okay, so the plot is called as root locus. All right, so we need to understand something. What exactly is the root locus, and what we get right by just looking at this kind of plot. So first let's look at the name. It says that it's the root locus. Locus in the sense it the way in which points gets connected to get a path, right? So that's a locus in the coordinate geometry, and root locus indicates that how roots move, or what path roots are going to create, right? So if there is a root to be created by the roots, right, then it means roots are going to move. Now already we have seen that whenever the gain of the system changes, we have roots moving around. So the path in which the roots move creates the root locus. All right, so let's start with the characteristic equation once, right? So in general, the characteristic equation of any system is denoted by, obviously this has to be a closed loop, we don't have to specify that now. So this is 1 plus the g of s into h of s equals to 0. Right now, let there be a gain parameter. Okay, so let k be a variable. This is a variable parameter, right? This, let's assume that this corresponds to the gain of the system. Again, gain represents the forward path. Okay, so of the closed system. So let's this implies, let's say the total g of s of the system is represented in the following format. This is k into some other g of s. I'll call this is g dash of s. Right, separate the gain from the g of s and call it as a k. Whatever remains is a g dash, right? It's like that. It's like if you have 2 into s divided by, say, s plus 1, this 2 becomes the k now, and the remaining s by s plus 1 becomes the g dash. Okay, so like that, this is the notation which we are going to give now, right? So now let's slightly modify our feedback system, just to make sure that we look at the k carefully. All right, okay, so let's modify the representation. Input is r of s. Input goes to a summing block. All right, so this has two parts. Now, usually we write a g of s here, but now I'm going to write a block for k and another block for g dash of s. The overall product is the g. this is going to generate our output, that is C of S, and we have the feedback that is on the other side, that is H of S. So output is taken from here, given it as input to the feedback path, that generates another output which is given as input to the summing block. So assuming this to be a negative feedback, I write a minus sign over there. Okay, now normally what I write, what is the characteristic equation that we are going to write? So if the 1 plus g into h is equal to 0, this is what we write for this given system. It has to be modified as 1 plus k times g dash, because k into g dash is the g, right, into h of s is equal to 0. This is what. So this is the k is the parameter now, right? So this k is going to alter our system's response, because this k changes means I have the roots changing their positions, right? So for example, yeah, sure. Please take your time, no problem. Okay, now so this k is the variable parameter we assume, right? It also corresponds to the gain of the system. Okay, now whenever I have this equation, that is 1 plus k times g dash into h of s, and the gain of the system definitely can be varied, right? So let's write, if k is varied, it can be varied because of two reasons. First reason is that it is assumed to be a variable parameter. Definitely you can vary. Otherwise, the k can also be varied for a reason that it is the gain of the system. When I design the system, I might try with various values so that I can get the desired output, right? Because the whole thing, if at all we consider this to be a second order system, and I want to design a say underdamped system of specified zeta and specified omega n, I might have to change the k, right? Because of the variation in the k value, I might get the appropriate graph, right? So definitely I'll change. So when this k is varied, right, I can say I will give a limit now. So the limit should be from minus infinity to plus infinity. So because it is a variable, you are going to vary, right? Now let's understand what happens in this equation. Mathematically, let's have a look at this. So it's like you can have a equation like this is 1 plus k is a some constant, right? So as of now you can put any value. One value I put, I get one equation, because g into h of s could be something like s by s plus 1 into maybe s plus 2, let's assume. Okay, this is equal to 0, but k is a variable now. You may put 1, you may put 2, you may put minus 3, etc. Every time you put a different value of k, the roots of this whole equation will change, correct? So that's why whenever I change the k gain of the system, right, the roots are going to change their positions. Correct. So as the roots are getting changed, right, we can see that you try to connect every route that you get when you vary k from minus infinity to plus infinity, you get a graph. Correct. So that graph is what is considered as the root locus, right? So why it is needed, what's the use, how this is useful in analysis of a system, etc. We are going to study that. Okay. So if k is varied from minus infinity to infinity, right? Each value of k, right, gets separate, I can say, set of roots, a characteristic equation, right? So this means I try to connect all such locations. Okay, so then I get root locus, right? The connect, I can write connecting all such roots, right, implies we get root locus. So that's the basic idea about a root locus. How, what exactly root locus means? That is this. Let's look at a very simple, just to understand this concept clearly. Let's go ahead and do something. All right. So this is an example to understand the whole concept. Okay. So let's say that there is a system with g of s is equal to a k by s. Okay. And let's say the h of s is equal to 1. Right? So I already have a k here. So separating k gives 1 by s, which is the g dash of s. Correct? From this. Okay. Now, what is the characteristic equation? It's a normal equation. 1 plus g into h is equal to 0. So this is 1 plus g is k by s, right, into 1 is equal to 0. So you see that this is 1 plus k by s equal to 0. So k by s is equal to minus 1. So I get s equal to minus k. Are you okay? So in the sense, so here I'm not trying to find k in terms of s. So I'm not writing k is minus s here specifically because k is the variable. S is, you are going to find s dependent on the k. And you vary the k from minus infinity to plus infinity. Now I understand that the root of the equation, there is only one root because it's a first order equation, one root, and the root is minus of k. Whatever k you take, the value will be minus of that. S is root will be minus of that. So now we know that. Let's try to vary the k from 0 to infinity, right? So it indicates that. So we can make a table, right? So k, and we'll try to find the s, right? S equal to minus k. So start with 0. This is 0. So when I put say this is 1, it becomes minus 1, right? 10 means minus 10, 100, etc. So I'll go to the last value, infinity, means the root becomes minus infinity, right? So let's look at this now. This implies, let's try to directly go for a plot. We understood what is happening over here. So let's directly go for the root locus plot. So root locus plot is the real values, real versus imaginary. I can write j omega. All right. So you are trying to plot the s only over here, right? And I'm talking about the pole. So this is the marking for a pole. So this is when when k is 0, s was 0. When k is 1, right, I got s is minus 1, s is minus 10, and maybe the s became minus infinity at this. So I can write s equal to minus infinity, right? So this is s is 0, s is equal to minus 1, s is equal to minus 10, and so on. So now I understand that the route is moving from 0 towards minus infinity. So connect everything. Okay, connect every point that's possible in this fashion. So you whatever you get is the root locus. Now this red line itself is a root locus. Very simple case. Okay, so I vary k and I plot. Okay, now in order to get this is a very simple what you call simple case, right? But the systems which we normally design are not so easy. They are pretty complicated. So in order to understand the plotting of the root locus of any given system, right, we need to know few more things about root locus. So there are some conditions. So the conditions that we need to understand from uh, the in order to understand the process of drawing the root locus, there are two cases, two conditions. Okay, so we'll come to the conditions in a while. So let's consider once again. Let's consider the closed loop characteristic equation. Okay, once again. So the example got over now. So we are continuing with the theory part. So let the characteristic equation, we consider once again the same thing. 1 plus g into h is equal to 0, right? So this actually, this itself is going to give us an idea about what should be the g of s into h of s for any given system. What should be this? This should be, take 1 to other side. This is minus 1, correct? In the sense, whenever you have g of s multiplied by h of s, right, satisfies minus 1 for different values of s, those s, right, are actually the root of the given system. And those s, all s, if you connect, that makes a root locus, correct? This is another view. All right, so this implies I can try to write anyway. What is s is in general, it s, any point on the s plane is complex, right? So this actually implies the g of s into h of s is a complex number. How do you write minus 1 as a complex number? Minus 1 plus or minus j0. This is a complex number. Now if you actually, we can, because why you are writing, because I'm always expecting sigma plus or minus j times omega. This is what we expect, right? So far, whatever we discussed, even including the example we consider, everything was real. Only the sigma value was there, but definitely the roots of a characteristic equation can be complex as well, right? So now, anyway, in order to understand that, so the roots can be, right, whenever we have okay, I'll put it in a different sentence so that this becomes easier. So whenever we say that g of s into h of s is a complex number, right, we know something. So we know that if you are writing a complex number, this actually has two parts, right? The first part is a magnitude, correct? And the second part of a complex number is the angle, correct? Now you see, any complex number will not satisfy the above equation, right? Only those complex numbers you put as s to the g of s into h of s, which generates a minus 1, will satisfy this equation. That means you have to have a condition on the magnitude and also a condition on the angle. So every number will not satisfy, every complex number will not satisfy, only specific, right? Specific complex numbers will satisfy this equation because of the magnitude and angle conditions. All right, so let's go to the detailed view of what exactly is this angle condition and what exactly is the magnitude condition standing for. Okay, so the first thing to understand here is the angle condition. Okay, once again, I'll directly go to the equation we derived so far. Whatever we know g of s into h of s is equal to minus 1. Now, what is the angle corresponding to minus 1? When I write minus 1, so convert this into a polar format. Can you tell me the polar format of minus 1? Because minus 1 is minus 1 plus j0, that's obvious, right? That is a rectangular format of our complex number, correct? So how do you write that? So this is equal to minus 1 plus j0. Now I want you to write that in the polar format. Polar format is r angle theta. Any alpha plus or minus j beta can be converted into r angle theta. So now you see the alpha plus j beta over here. Convert that into r angle theta and tell me the answer. Sure. Yes. Yes, if you are using scientific, there will be a direct notation like r angle theta, I guess. There should be one button which directly converts. You just have to enter the number, okay, and that number gets directly converted into this format when you press that button. In my scientific calculator, I have to press shift and then I press that button. Maybe it's located somewhere. I don't know the ES format. Mine is a MS 991 MS, slightly older version. Sure, sure. Take your time. Okay, okay, okay. It's there, right? Okay. Okay, so that means if I write as a minus 1 plus j0, this is actually converted as 1 angle 180 degrees. Okay, that's fine. Now let's come to the visualization of this on a graph. All right. So let's say, fine. So this is the one which now let's write the minus one somewhere here. Let's assume that this is the minus 1 plus j0. Yeah. Okay, so that corresponds to what is the magnitude of this according to the above polar format. It says that the magnitude is 1, right? 1. So yes. This distance, if I measure, right, this distance is equal to 1. So I'll write something like maybe, okay, magnitude is 1, let's write. Okay, fine. Now, it said that the angle is 180 degree, right? You tell me how you, with respect to what you are measuring the angle. So it means, so whatever red line I have drawn here, right? So that red line makes 180 degree is the statement. That's what the one angle 180 says. Magnitude is 1 and it makes an angle of 180 degrees. But my question is with respect to what? Where you are measuring the 180 degree, or if I say one angle 90, right, this 90 degree is measured with respect to what? So in general, you see, when we say 45 degrees, right, I may have two lines. So this is 45 degree, in the sense I am measuring this with respect to this. So in this case, now my question is, this is measured as 180 degree with respect to what? Where is the other line? Right, so it's a real axis, correct? So, yes, so positive real axis to be more precise. Fine, that's correct. So that means, okay, let me draw this. So actually I am measuring the 180 degrees over here, correct? Now I have a question, is this the only answer? Right, so can, which means minus 1 plus j0 is equal to 1 angle 180. Is this the only answer, or do you have equal to something else, equal to something else? Can you fill few more points, or is this the only answer? That's my next question. Single answer. Okay, what about this angle? What if I measure the angle in the opposite side? Maybe your convention will change. So what is that angle? How much is that angle? This is 180, but since you change the direction, right, our convention says that this is minus 180. Okay, all right. So anyway, I got one of the answers. So I'll extend the same question once again. So are these two the only two answers you have, or can you extend further? Anyway, I got one more answer now. So this is equal to 1 angle minus 180. Okay, so do you have? Okay, okay. Now what I do, I will move around this circle in this fashion. So what is this angle now? How much angle I covered? That's still I reached the 180. This line itself. Now in trigonometry we know some, you can apply some basic trigonometric rules to identify different angles. So theta is also equal to theta plus the 2 pi or 360, correct, which is also equal to the same theta plus 4 pi, and so on, right? So now how do you generalize this? So in other words, I'll try to write something. So this means whatever we discussed so far, this is corresponding to the theta, which is the angle, is equal to one. First thing is plus or minus 180. This is the answer. Next, you add 360 to that, which means I started from here, I move around. This is how much? This is 360 plus 180. 360 plus 180 is how much? I think 540. So 180, it's also equal to plus or minus 540, right? That is because I might start from here, I go like this, I come, this is 3 minus 360 minus 180. So I still reach the line, so this is plus or minus, I have to write 540. Definitely you have another answer coming up, right? Comma, plus or minus whatever, right? You tell me a general version at the end. I want, right. So now my question is that can you give a general equation by using a variable, right? 180, 540, consider the next number, right? And then you try to generalize. Yeah, you can use 2 pi or 360 over there. That's correct. Correct. But what is the general equation? You can actually try this way, right? So what you did here is, this is maybe simply plus or minus 180. I cannot alter this. Now the second one you can write, you see that this is plus or minus 180 plus 360, correct? What will be the next number here if you calculate? So this 540 plus 360. Okay, so this comes to be plus or minus 900. So I can write that number as plus or minus, this is 180 plus 2 times 360, isn't it? Now you extend the same thing and try to get a general format. So the next number that's going to come here is plus or minus 180. I'll put a bracket, okay? Plus 3 into 360 will be the next number, right? So now you generalize that 1, 2, 3, what you are writing there, make it as make it as some common this thing, some maybe I, J, K or whatever, right? Bring a variable over there, and that's the general equation, correct? So uh, 2, okay, n into 2 pi. That's what you are writing, correct? Okay, 180. Then you can write it as a replace 180 by pi. Okay, that's one way of answering. Otherwise, I'll write in this way. So this is plus or minus. Both will write. Okay, in degrees as well as radians, we can write. So first I write the degrees. This is 180 plus or minus. You told 2 times or in general. So I'll just write n times 360. Is it okay? N into 360. I'll take a 180 common from this. Plus or minus 180. I'll write later. So this is 180. It's going outside. So I'll write into 180. This is plus or minus. Oh, not plus or minus. My mistake. Because inside the bracket I have only plus. Plus or minus is already outside. So I don't have write. I should not write a minus now. Okay. So it's just plus. Okay, right. So this is now what happens? This is n into 2, right? So that's right. So this is equal to plus or minus. I'll modify. This is 2n plus 1 into 180. But what values we are going to put for n? N is equal to, n will definitely start from 0, right? 0, 1, 2, dot, dot, dot. Now you tell me what, when you put any integer value to this term, what is a 2n plus 1? N is any number, any integer, right? Any integer you put over here for n, what is 2n plus 1? You might observe something. When you put few values, 0, 1, 2, 3, 4, something you put over there and identify what comes as the 2n plus 1. Correct, scaling factor. But what is the character? When you put 0, what happens to this? It is 1, correct? When you put 1, when you put n equal to 1, it's 3. When you put n equal to 2, it's odd number, indicating that everything is a odd multiple of 180. So that's our angle criteria. Actually, our side heading was angle criteria. We started from there, right? Now we ended up in the angle criteria. So if you want a s, a root of the equation to satisfy, right, to be present like this, right? Okay, if you want a root of the given equation to satisfy the condition that g into h is equal to -1, what should be the angle, right? The answer is angle of that s should be, this implies I can write theta. For any theta it should be odd multiple of 180 degrees, right? Odd in the sense positive or negative, doesn't matter. So in terms of in a mathematical notation, you can write this. The textbooks will follow this. It is angle notation. Angle of g of s into h of s, right, should be, right, like this. This is plus or minus 2n plus 1 into 180 is the condition. This must be satisfied by any uh, any s that is present on the root locus. Any root that is expected to be a solution of the characteristic equation should satisfy this condition. Okay, all right. Now let's go ahead. So then there is another condition, right? Because a root can be complex. As soon as we see that a number becoming complex, we have two options. One option is it has a magnitude, so you will put a condition on the magnitude. Second thing is that it has a angle, so we have definitely a angle condition coming into picture. So now you see we have the second condition, that is the magnitude condition. Yeah, every plot, correct. So definitely polar plot, right. Hmm. Yes, correct. So you try to keep the magnitude as one, and you calculate the number of times you are going to rotate, make the rotations, right? So that gives you the uh, that gives the idea how to plot the polar curves, right? Okay, fine. Now let's come back. Now we once again start from this equation. I have g of s into h of s. This is equal to 1, minus 1, right? Okay, because 1 plus g into h is equal to 0. Now, what happens if you take magnitude on both sides? Can you tell me what is magnitude of g of s into h of s equals to? It's 1, right? It becomes 1. Now, once again, we come to the same concept, right? You have the given system, right, which has a characteristic equation 1 into h is equal to 0, right? So, angle says that, okay, there has to be an angle of 180 degrees or integer multiple of 180 plus or minus. When you remove the angle from there, whatever remains is the magnitude, right? So that magnitude has 1. It has to be 1. So magnitude condition is that at any point in the S plane, right? Any point in the S plane indicates that it has to be on the root locus. If you want that point to be on the root locus, then the magnitude of G into H should be equal to 1. Yes, right. So if we say that yes, this is a properly designed system, and one of the root which you find out for that given system, if it is present on the root locus, then magnitude of that g into h is equal to 1 at a given point s. Okay, s can be real, s can be complex, right? We can put over there, and we just have to verify that whether it is present on that or not. Now, okay, now let's see the whatever we studied so far, right? Can we apply somewhere, right? We'll see that now. All right, fine. This is an example. Okay, fine. So if G into H is equal to, say, K divided by S into S plus 2 into S plus 4, if this is for a given system where S is equal to minus 0.75 is on root locus. It means they say that yes, this is a root and this root is present on the root locus. Uh, then find k. So this is the question. What's the value of k, right? So that, right, the s equal to minus zero point 0.5 is present on the root locus. Right. So that's a question. Try to answer it. Either you will apply the angle condition or the magnitude condition. One of them you can use because we don't have any other option. We have not studied anything else as of now. Right. Yeah. Okay. You please try this straightforward. Okay. For which one? Yes, yes, yes. You can do that. Yes, yes, yes. Yeah, sure, sure. As you told, we have to go for the magnitude condition, right? The magnitude condition says that the magnitude of the g of s into the h of s at the given point. What is the point? Point is s is equal to 0.75 should be equal to 1. Correct? So let's write that. What is g into h? Ha. Okay, all right. So s into the s plus 2 into s plus 4 at s equal to minus 0.75 should be equal to 1, right? So this is k, this is minus 0.75, its magnitude anyway. So this is minus 0.75 plus 2, so that is I think 1.25, correct, into same thing, 4 minus that, so this is 3 point something, 3.25, right, is equal to 1. Again, this is a magnitude, right? So k is equal to, take a magnitude, cancel the minus sign, so this is simply 0.75. Okay, 3.25. 3.05. Okay. So that's the value of k, right? Uh, Sorry, how much? Three point something, right? Okay. Now, what if I say, let's assume that I don't know this point s equal to 0.75 is present on the root locus, because in this statement, previous problem, uh, the statement itself says that s equal to 0 point minus 0.75 is is on root locus, is a root. Okay, it's mentioned. That's why we could proceed here, right? Okay, but now let me modify the same question. No, S value might not be given, or it can be said that, okay, so I'll modify the question. If G into H is equal to same thing, okay, same this thing, S by K by S into S plus 2 into S plus, say, 4 was the case, right? If this is the case, check. I want you to check now. Okay, check whether the s is equal to minus 0.75 is on root locus, and I will specify, say, using angle condition. This is a question. Okay, now you have to use the angle criterion to find out whether it is present or not. So what is the angle criterion says? Angle criterion says that angle of G into H should be integer multiple of 180. Correct? So this is plus or minus 2 times n plus 1 into 180. Right? I expect that either 180 should come, or 540 or 900 or so on. Anything should come whenever you calculate the angle of this term, where s is equal to minus zero point 0.5. I just have to check. If the answer comes to be yes, 180 minus 180 plus 180, 540 minus 540, or anything like that, then you say that yes, it is present on the root locus. If it is not, then you say it's not present on the root locus. So that means plot is not needed. Directly you can calculate this. So when I say angle, it means I'm supposed to calculate the angle of k, because I don't know what is that k. Correct? You don't have to find a k at all, right? Keep the k, right, as it is, no issues. Angle of k, and angle of s, angle of s plus 2, angle of s plus 4. Do this. So again, angle becomes, I just have to substitute in the same fashion. All right, so you can see that this is what is the angle of k. K is a real number. Whenever you have a real number, how do you find out? So I'll come to one general concept. If you have alpha plus j beta, right? Yeah. How do you convert this into the theta? Theta is nothing but tan inverse of beta by alpha. Now do the same thing. Take k as k plus j 0. No, no. Okay, tan inverse of, see, beta is 0. So b 0 by k. Correct? So tan inverse of 0. So let's correct. So this is, now I can, so this is equal to, first term is tan inverse of 0, and the next term, so since it is in the denominator, it is minus, right? Tan inverse of what is that number? I have to make s is equal to minus 0.75, then minus tan inverse of 1.25. Correct? 1.25, and next one is plus, so not plus, minus tan inverse of, sorry, this is actually not, imaginary part is 0 and real part is minus 1. Okay, so this is, hey, yeah, okay, you tell me the answer. Final. This is 3.2. Don't take this as a angle. Okay, this 3.25 is not angle, right? I cannot take tan inverse by just applying, using a calculator. So you understood, right? Because this is not angle. 3.25 is not radian. So what is this answer? So tan inverse of 0 is 0, right? Anyway, that's fine. Uh, what is the second one? Minus. No, that's okay. You give me anything. Anything is fine. Hmm. No, no. See, that's what I told. This minus 0.75 is not angle. Okay, it's not the value. So I cannot take the tan inverse using calculator. That's what I told. So use the concept which we discussed so far. If I have a point which is minus 0.75, what is the angle? 180. That's what should come here. Okay, so you apply that. All right. So this is minus 180. Then the next number. You see that this is positive. 1.25 is here. So no, no, no. 1.25. It's here. Real axis. So what is the angle? 360 means easier number is 0, right? Good. Okay. So this is right. This is 0. This is also 0. So your answer is minus 180, which satisfies our condition, right? This satisfies plus or minus the 2n plus 1 times 180 rule. Okay. So because this satisfies the condition, right? This satisfies the condition. We can say that yes, this is present on the root locus, right? That's the answer.